Hi everyone, welcome to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based in Singapore. In this session, Win Wu is going to talk to us about Cloud Spanner, Google's global, strongly consistent, mission-critical database. Remember that at any time you can ask a question below, and we have technical experts standing by and ready to help. Win Wu is a customer engineer based out of Australia, and we'll pass it to him now.
Hello and welcome back. This is Google Cloud on Air TGIF edition. My name is Win Wu, cloud engineer from Sydney, Australia, and this is Cloud Spanner 101. I'm joined by our host, Jay Jenkins from Singapore, and on bass guitar is Hillary, and on drums is KJ Patel. So they'll be joining me for the QA session later on today. So let's map out the goals for today's session. So this session is going to be about some very unique technology that Google's been using for its own businesses for a while. So it's a relational database platform that scales horizontally across the globe. But before we go into the interesting aspects of the technology, it's useful to understand a bit of the context of why we built this technology in the first place. And it was to solve some unique business challenges that we actually had within our own business. So I'll describe a little bit about what those challenges are and the situation that we came from and what Spanner actually allowed us to do in terms of solving those particular problems. And then secondly, I'll be going into a bit of a overview as to how the technology works underneath the covers. So whilst Spanner is a relational database that most people that are familiar with in terms of a relational database structure with relational semantics and SQL queries and so forth, it's a little bit different in terms of how it works under the hood to allow us to essentially do horizontal scaling across a distributed system. So what I'll do is basically provide a first level explanation as to how that technology works under the hood and how basically you can use it to exceed the performance that you typically get out of a relational database system. And then thirdly, no session is basically complete without some sort of demo or walkthrough. So I will be going through a bit of a basic demonstration to show you what Cloud Spanner looks like from a database administrator standpoint, as well as from somebody that would be using the system by building applications and writing SQL queries against the database. So I'll be going through how that sort of looks like within the Cloud Platform console environment. So that's basically the objective or the structure of today's conversation. So first off, let's go through a bit of a background as to why we built Cloud Spanner in the first place. And in order to do that, we had to basically, we basically need to do something. And what we need to do is we need to rewind time a little bit back to the year 2005. So this is more than a decade ago. But the reason why we're dialing back to 2005 is because this was a time where we were seeing a lot of growth within our business in terms of the tremendous success of the Google AdWords platform. So Google runs for its own systems a very large distributed infrastructure in order to deliver critical platforms that businesses use today, such as Google AdWords, Analytics, and indeed Google Cloud Platform. But back in 2005, we didn't actually have the benefit of Google Cloud Spanner to do all this. We actually were using a MySQL database-based environment. And in order to deal with the massive volumes of data within cloud or within the Google Cloud, we essentially were distributing that data across multiple MySQL environments. And then in order to accommodate that scale, we were manually sharding that data across that database environment. So we had lots of different standalone MySQLs, and we were sharding that data, if we're talking about Google AdWords, we were sharding that data across different databases by customer ID. It got to a point where we were really reaching the scaling limits in terms of what the platform could actually provide. So the last time that we actually did a database reshard in order to accommodate the tremendous growth of the AdWords system, that database reshard by customer ID basically took more than 2 years to perform. So as you can imagine, that's not really agile from a business sense, neither from an engineering sense. So we really had to basically think about new ways to solve this problem. And in order to do that, we had to go back to the drawing board to think about new ways and new ideas and really innovative techniques in engineering to think about how we can scale beyond the typical restrictions of a relational database like MySQL. So after doing our database reshard, we went back to the drawing board and had to think about what our high-level requirements actually were. So the first requirement is fairly obvious. So we're enjoying the benefits of horizontal scalability to accommodate the high throughput queries per second and the volumes that we're seeing in terms of Google searches and the other things that you enjoy from Google on a daily basis. So we wanted that horizontal scalability for our database platform layer as well. So that was requirement number one. Traditional thinking at the time dictated that horizontal scale within the database layer meant you'd go with a NoSQL key value store style solution, but you'd have trade-offs within those systems. And those trade-offs typically translate to lack of SQL support. You don't get strong consistency of that data. So typically, if you're using with a horizontally scalable database environment, you would basically get higher performance in terms of reads and writes, but you don't get that strong consistency guarantee of a relational database. That was something that we couldn't actually compromise on within our environment. And the reason for that, if we're talking about AdWords, is the sense that we're actually dealing with some critical systems that needed to deal with data in a strongly consistent way. So we're dealing with things like monetary events or events that would affect things like how ads are being consumed and how that would affect how people are being paid on those ads. And for that sort of solution, we need to basically have strongly consistent transactions. So these are ACID transactions alongside the horizontal scalability as well. So that ruled out other systems from the NoSQL world that would provide those weaker guarantees that you typically get in that world. The third requirement is around no downtime. So when you need to perform database maintenance, you typically need to take that database offline. So either to do schema updates, or you need to basically patch the underlying systems for your servers. We couldn't actually suffer that within critical environments like Google AdWords. So these were systems that were generating revenue for Google as well as our customers. And we couldn't basically take these systems offline to do things like scheduled maintenance. And we've already experienced how difficult it was to basically take these systems and then try and manually shard that across multiple relational databases and deal with the complexity of keeping these systems up whilst shuffling underneath the covers in terms of keeping the database environment available so that the application could still remain online whilst we're changing schemas or patching servers and so forth. For our new system, we wanted a way to basically not have downtime, whether that's for events like database schema updates or patching the underlying systems to deal with new functionality or for security patches or whatever happens to be that requires some form of maintenance. So that basically brings us to Cloud Spanner. And these were the reasons from an underlying Google business perspective that drove us to build such a system. So in order to give you a bit of a flavor as to what Cloud Spanner looks like and the sort of things that it allows you to achieve, I'd like to roll to a quick video to give you that overview. So can we please roll to the video?
We demand a lot of our databases, and our databases demand a lot of us. They're fragile, expensive, and tough to maintain. When things break, it can be hard to put the pieces back together at the speed of your business, and you often lose data in the process. We've all come to expect that distributed databases can't be globally consistent and scalable. But what if you didn't have to make trade-offs? What if you could have a fully managed database service that's consistent, scales horizontally across data centers, and speaks SQL? This is Cloud Spanner, a mission-critical relational database service built from the ground up and battle-tested at Google for strong consistency and high availability at global scale. At Google, we use Spanner for services that billions of people access every day. It's the only cloud service designed to be a massively distributed relational database with transactions and SQL semantics. And we're talking massive. Spanner can scale up to millions of machines across hundreds of data centers and trillions of database rows, stretching across the globe while behaving like it's all in one place, where you want it. We've built Cloud Spanner to be fully managed and secure. Automatic sharding and synchronous replication with low latency and schema updates without downtime means your data is highly available and reliable. Instead of endless provisioning and worrying about maintenance, you can focus on growing your business. No matter your needs, you don't have to hit a wall with your database service. Get started with Cloud Spanner and build what's next.
So let's cover off the main points within that video that we just saw then. So if we were to look back at what are the main features of Cloud Spanner, it's a fully managed database service from Google for mission-critical applications that provides you with relational semantics and also gives you the ability to scale your database across the globe. It's also a database that breaks the traditional notion of the consistency guarantees that you would normally get out of a distributed database environment, in the sense that it gives you external data consistency and ACID transactions on top of that distributed infrastructure, which is something that you typically can't achieve with a normal non-relational database. So it gives you full ACID transactions, and we also support SQL in the sense of standard SQL or ANSI 2011 compliant SQL with extensions as well to work with your data and the schemas that you actually have within your database. We also perform, as part of a fully managed service, automatic synchronous replication of your data across multiple replicas. Today, within the Google Cloud Platform environment, you have the ability to create regional instances of Spanner. So this allows you to create instances of Spanner within any of our Cloud Platform regions and have your data replicated across the zones within that Cloud Platform region. So that's Cloud Spanner Beta. We'll be later on in the year also providing multi-regional deployments of Cloud Spanner as well. So what that means is you're able to create Spanner instances which span across multiple regions across the globe. And that'll give you higher availability than even what you get today with regional deployments. With the regional Cloud Spanner instances that you get today, that's giving you 4 nines worth of availability. Once we launch the multi-regional capabilities, that will give you 5 nines worth of availability. And someone here has done the math for me, and I believe that equates to about 2 seconds worth of downtime every month. As a developer or as a consumer of a database, typically that is a transactional retry if it does go down for 2 seconds. So in practice, you'd be very hard-pressed to even find that downtime or be impacted by that. So there's incredible levels of availability from our distributed infrastructure that we provide as a unique service or unique capability within the Cloud Spanner service. So although Cloud Spanner is a new technology from the Cloud Platform front, it is actually a technology that we've battle tested within Google for a number of years. So it underpins some of our most critical systems. AdWords runs on Cloud Spanner. Google Play runs on Cloud Spanner. And now you're able to leverage the same battle-tested, mission-critical capabilities and characteristics from the same platform within your own applications. It is the same underlying platforms that we utilize and rely on, and is the lifeblood of many Google services today. To make it simple to compare the different database offerings that you see within Google Cloud, as well as from a more general perspective, we put together a bit of an eye chart to compare the characteristics of Cloud Spanner, what you get from a traditional relational database, and what you might get from a traditional non-relational database, such as a NewSQL environment that provides you with a document-oriented structure or a key value store. So let's go through some of these characteristics in turn. So let's first talk about the schema. With a relational database, you enjoy the benefits of a relational schema that's strongly typed, uses strongly typed SQL data types, and you typically interact with your schemas in your data using something like SQL. Cloud Spanner gives you those same relational semantics, but in a distributed environment that allows you to scale beyond the limitations of a single node. Compare that with a traditional non-relational environment, and you don't get that same strongly typed schema, and you don't have those same schema guarantees that you typically get out of a relational environment. Typically, you get something else that is going to be specific to that environment, whether it's more of a JSON-oriented or document-oriented database or a key value store or wide column key value store. It's going to be something that's not going to be of a relational structure. So if you need a relational database that can span across the globe, then Cloud Spanner will give you that functionality, and that overcomes the limitations of some of the traditional relational databases that you see today. The second is around SQL compatibility. So I mentioned that Spanner is SQL ANSI 2011 compliant with extensions, and that allows you to essentially use the same open standard SQL that you're using today for your own applications that might target a traditional relational database environment. So in a non-relational environment, you might not be using SQL because it doesn't make sense for the data structures and schemas involved in those environments, and typically a lot of NoSQL environments are actually schema on read, so you get flexible schemas, but that's sometimes not what you actually want, right? In terms of Cloud Spanner, we give you that compliant SQL that you're familiar with on an everyday basis that you're using today within MySQL or some other traditional relational database, except you get the benefits of essentially that horizontal scalability within the environment. Strong consistency guarantees is also something that's quite unique to the Cloud Spanner environment. So as I talked about before, with a typical non-relational database or something that you scale horizontally, you typically trade off the performance that you get for weaker consistent guarantees. With Cloud Spanner, we actually adhere to the strongest notion of data consistency, and that's external global consistency that you get for all of your transactions, no matter where they occur across the globe or within a region, if you're talking about regional deployments. So it's really combining the benefits of ACID transactions across a replicated data store that represents your database that can be living in a single region or across the world. So you're really getting the best of both the relational, strong consistency world and the benefits that you get around scale out, horizontally scalable NoSQL databases. The scalability of the system that you get within Spanner is phenomenal. So with a relational database environment, you have some limited scalability choices that you can think about if you exceed the limitations of a single node. For example, master-slave replication is quite common within a typical traditional relational database setup, where you have a single master for your reads and writes, and then you scale out your reads across a number of slave or read replicas. But that doesn't allow you to achieve horizontal scalability for both your reads and your writes. What Cloud Spanner gives you is the ability to have synchronous replication in a scale-out manner that allows you to scale out all the different access patterns that you might need from your database, not just in terms of the reads. Something that we do in terms of the replication is we actually do that in a synchronous manner, which means that you also don't get the lag in terms of updates, in terms of synchronizing the data between a master replica and then the slaves that you might then attach off that. So it's all synchronous data replication, and that's part of our global consistency story that's very compelling with Google Cloud Spanner. And then that touches upon the last point. The replication is part of the managed service. So you don't actually need to go and set up read replicas. You don't need to go and set up the replication characteristics or any of that sort of setup. It's basically provided for you within the platform. All you need to do to create a Cloud Spanner instance that's horizontally scalable with synchronous replication is select your region, or in the future, it'll be also an option to set it up from a multi-regional perspective. And then we perform all the replication underneath the covers for you. And that takes away a lot of the administrative effort and overhead in terms of providing or having a fully replicated, horizontally scalable setup. So let's talk about some of the open standards, or rather the effort that we've had to go through in order to expose Spanner or to have Spanner available as a cloud platform service externally. So in terms of that effort, the effort involved in delivering something like Cloud Spanner was not actually creating the service itself. Sure, back in the year 2005, we actually had to go and create that service. But in order to deliver Cloud Spanner as a first-class database service that's consumable not just by Google, but for external developers and organizations worldwide, we had to think about how we can conform to open standards that you're using today for the reasons of simpler integration or portability between different databases, and allow for more seamless integration in general. So a lot of effort went actually into adhering or making Spanner compatible and adhere to the open standards that you're actually using today. I talked about what some of these were in some of the previous points. So the first is around ANSI 2011 or standard SQL compliance. Spanner will support that same open standard that you're already familiar with and perhaps using today for your own databases. The second is around enterprise security, compliance, and audits and controls. So if you're a large enterprise organization, you're probably going to need an understanding of who's doing what to the database, who's altering the schema, and then have all that basically tracked in an audit log. So Google Cloud Spanner not only provides an auditing capability, but because everything within Cloud Platform from a storage at rest perspective, as well as within transit within the network, whether that's from the client to Cloud Platform or within Cloud Platform itself, everything's encrypted by default. And that basically means that your data is secure, whether that's data that you're storing within the environment at rest, or whether that's basically data that's being communicated between different systems of our stack, as well as to the applications that you build on top of our databases. Having a great client developer experience or having great developing experience is one of the critical aspects of our launch criteria. So out of the box or out of the cloud, we launched with a number of idiomatic client libraries, which gives you first-class integration and capabilities for your favorite languages. So the idiomatic client libraries that we have today are for Java, Python, Go, and Node.js. And if you're not using one of those languages, there's also a REST-based API, as well as gRPC support as well, if you then want to target languages outside of that. Or if you want to go and target those layers specifically, then you're free and available to do that as well. The JDBC driver was also a critical part of the story in terms of the integration story that we wanted to provide with Cloud Spanner. So many systems today use JDBC drivers to talk to the database. So what we did was we created a read-only implementation of a JDBC driver that supports Cloud Spanner. And that basically means you can plug other systems that are already talking using JDBC to the database layer, and then use Spanner to basically power the underlying database. So you can talk using the JDBC driver to Spanner itself. And this was also the reason why we've been able to launch with a number of partner integrations on day one as well through that JDBC driver support. And I'll be talking about some of that partner ecosystem that we launched with later on in the presentation. In terms of the types of workloads that would fit really well for Cloud Spanner, I just wanted to cover some of those particular workload characteristics where you might pivot your thinking towards Cloud Spanner being a great environment for that kind of workload. So a common misconception is that you need tons of data to basically justify Cloud Spanner. But it's actually a little bit more complicated than that, or perhaps a little bit more expansive than that. Sure, Cloud Spanner can actually operate on lots and lots of relational data, and it's a great environment for basically that sort of criteria. But it's a little bit more expansive than that. Let's go through into some of the workload characteristics that would make a lot of sense for Cloud Spanner. The first is transactional workloads. So let's just say that you've exhausted the limitations or exhausted the ceiling of scalability or performance with your traditional relational database environment. Cloud Spanner will basically give you the same relational semantics as well as strong consistency that you expect from a relational database, but also provide you with horizontal scalability so that you can exceed or break the ceiling of what you were experiencing before with that relational database. So for any sort of transactional workload where it's gone beyond what you can achieve with a single master for read and write access patterns on that single node, Cloud Spanner will give you an easy way to basically scale beyond that. The second is for scale-out workloads. So for whatever reason, if you wanted to scale beyond a single node, and you also wanted to scale out not just reads, but also for writes within your database, then doing that within a relational database environment is not necessarily all that simple. So there's different replication setups that you might think about with an RDBMS, whether that's master-slave or whether that's multi-master if you really want to go down that path. But unless you can really deal with the complexities and the management of dealing with things like multi-master environments and think about how things like data drift and other problems that occur in those environments can be managed, you want to avoid those environments. Cloud Spanner gives you an environment that performs scale out of your data across a cloud platform region as well as across the globe later on in the year, in a sense that will also allow you to scale out both your reads and your writes. So it's a really powerful capability to have within a fully managed database service. The global data plane use case was actually something that drove the cloud platform usage of Spanner. So today within cloud platform, we actually use Spanner to manage the resources or keep resource records of everything that you create and consume within cloud platform. Because cloud platform is a globally available system, we need the ability to view or to query and to mutate data from anywhere around the world and have a consistent view of that data. So the global data plane use case is really strong with Cloud Spanner. We could basically distribute data so that that data is closest to the customer wherever they are around the globe, but yet be able to have a consistent view of that data, whether you're querying that from Asia or from Europe or anywhere else around the world. So you don't need to have large volumes of data to justify the usage of Cloud Spanner, and that's a great example workload characteristic where we're taking the advantages of Cloud Spanner in terms of that global consistency of the data and then leveraging that characteristic for that type of workload. And then the last point is around database consolidation. So let's just say that you're using multiple databases where you're perhaps using some relational databases for strongly consistent data or relational data that you want to keep that environment. You're using some NoSQL databases in order to take advantage of the horizontal scale. And then you want to basically combine that data for combined insight that you get from joining those data sets together. Doing that across different database environments can be very challenging. If you're able to basically consolidate your databases into Cloud Spanner, which will give you both that horizontal scalability for your highest throughput databases through to the databases that you're normally having on a relational database management system, and be able to join that data or to be able to query that data freely within that environment, then that will unlock a lot of capability and a lot of insight that you would normally have to jump through a lot of hoops to achieve. So that database consolidation use case is also very strong. So from this point on, I want to dive into a little bit about how Cloud Spanner works underneath the covers. So this will be an overview of how we perform the data replication and explaining a bit of the magic of how Cloud Spanner works. If you want to know more about or dive more into the sophistication of the techniques that we're using, I encourage you to look at the Cloud Spanner 201 session that's on YouTube, or perhaps also look at the Cloud Spanner white paper as well. That will give you a full description of the capabilities of the platform and how they were achieved. But let's go with the overview here. And within the slide, this is an example of a Cloud Spanner instance that's spanning across a cloud platform region. So within a region, we have multiple zones. And when you create a Cloud Spanner instance, it will create a replica for each zone within that region. In this example, we have 2 databases spread across 3 zones, and then your data is replicated across those 3 zones. Each of those replicas in each of the zones has a complete copy of that data. So it's available, so that's how we also achieve the highly available nature of the system. And it's all fully managed, where you don't actually need to go and manage that replication yourself in terms of setting it up manually. Let's see what happens when a database update comes along. So let's just say that you want to update 10 rows or 100 rows in your database. So although each replica actually has a full copy of your data, there is a node that is the write master for that particular set of rows that you want to mutate or update. So the update goes to that node that owns that logical set of rows that you want to update, and then that write master essentially coordinates through a custom Paxos algorithm a approach where we synchronize the data in a synchronous manner across the other replicas that also contain that data. So all that's basically handled underneath the covers for you. We also perform two-phase commits where we actually need to. So for example, let's just say that you need to have a transaction that operates across multiple rows owned by different nodes within the system. We'll basically do that via a two-phase commit, but we'll also basically not fall onto a two-phase commit if we don't need to for performance reasons. No matter what we actually need to do underneath the covers, it's transparent to you as to whether it's going to be a two-phase commit or not, so that you can understand what the performance characteristics will be, as well as basically provide you with high performance in either case. So whether it's a two-phase commit or not, it's going to be milliseconds underneath the covers to perform a transaction typically. Let's look at a typical relational data layout that can better illustrate what that sort of looks like from a logical perspective or from a user of Cloud Spanner's perspective. And this table here, or the set of two tables rather, might show how two tables are related in the sense of singers that you want to keep in a table, or more accurately bands, and then the albums performed by those bands or singers. So within the singer table, we have a singer ID, which is a primary key, and then it's identified by an integer, and then we have the singer name. Within the albums table, we have the singer ID, which allows us to map the album ID back to the singer, and also a discrete, that was a singer ID that maps back to the singer table. And then there's an album ID that uniquely represents the album name. So in a traditional relational database, you'd basically have a primary foreign key relationship between the two, linking by singer ID. Within Cloud Spanner, because it's a distributed system, we've had to do some creative, interesting things to how we actually store that data. So within Cloud Spanner, in order to optimize the performance characteristics of interrelated rows, such as related by primary key here, we actually have what we call an interleave data format, where we interleave child tables with the related rows to the parent record within the records of the parent rows themselves. You can define what those strongly grouped relationships are within the DDL that you would use to create those tables, which actually means that you have full control of how your data is actually grouped together and sharded in the system. So although there's a lot of magic in terms of the synchronous replication and how that's basically accomplished within the system, you actually have full transparency as to how that data is basically organized within the system, and then you can structure that or optimize that for your particular reads and writes and the particular SQL queries that you need to perform. Let's look at that from a relational data model perspective, in the sense of what does it look like when I write a DDL which creates my tables. So this would look very familiar to anyone that's basically familiar with creating tables within SQL. There's some interesting aspects in here. For one, there's a clause that would basically have albums be an interleaved table within singers. And then because the albums table is interleaved within the parent table singers, the primary key for album basically becomes a composite key that combines with the singer ID and the album ID. So that's basically how you create the child and parent interleaved relationship between those two tables. I mentioned that we can also do schema alterations without any downtime whatsoever. So in the bottom of the slide, we see a sample alter table statement where we're adding a column called age. You can actually do that without any sort of downtime. So you can continue to have your application be available without having to take a master node offline to do a schema update to then accommodate some change within your database environment. Within Spanner, everything remains available across that schema update. Spanner is a very powerful database service, but is actually a member of a wider family of Google Cloud Platform databases. So I want to talk about what some of these different database offerings are within Cloud Platform and how they compare. So Cloud Spanner can do a lot. It's a relational database with horizontal scale, but sometimes you don't need that. So let's just say that you wanted to have a MySQL database and the requirements of your application dictated that that was enough for you. You could actually have a fully managed database instance like a MySQL instance, or today with Postgres using Cloud SQL. And you can have that as a fully managed service within Cloud Platform if you don't need the horizontal scale characteristics of Cloud Spanner. Cloud Spanner, on the other hand, would be great for all the workloads that I talked about in terms of the characteristics that you need for scale out, global data plane, and strongly consistent transactions across the globe. So Cloud Spanner is available for when you hit that performance ceiling that you get with MySQL and with Postgres potentially. Not all of your data could potentially be relational. So if you want to use a NoSQL database for your document-oriented style data, or perhaps you're looking at a wide column key value store for your analytical workloads, you could potentially look at other offerings within NoSQL space that let you have that horizontal scale, but doesn't provide you perhaps with that strong consistency guarantee, because you don't need it. And in that case, you might use Cloud Data Store, which is a document-oriented database to power your web application, for instance. Or you might look at Cloud Bigtable, which you might use to perform high throughput reads and writes against a wide column database that you can then crunch within some sort of distributed data processing system, like Hadoop, for instance. If you're not storing relational or structured data in any sense, then you might look at cloud storage. And that provides you with a highly scalable environment where you can store binary large objects up to 5 terabytes in size with unlimited scale, unlimited number of objects in a fully managed environment. And that's available for you as an option as well for those sort of data types. And then lastly, if you're looking at more cloud data warehousing and your SQL queries are more like analytical queries performed against an aggregate data warehouse, then you might look at BigQuery, which is our cloud scale data warehouse that supports petabyte scale data sets and lets you query that data and get back a result in seconds. So depending on what you need, there is a database service that's going to be the right fit for you. And in that sense, I don't have time to go through the full workflow or decision tree here. Perhaps if you're interested, you can go back and look at the recording. But this is a nice flowchart to help you decide and understand what might be the best database offering for you. So if you need low latency updates for your structured relational data, perhaps you'd use something like BigQuery. Or if you need to not have, or you're not working with relational data and you don't need mobile SDKs, you might use Cloud Data Store. So I'll leave this exercise to you as the viewer to have a look at what makes sense for your workloads, and this will be available in the recording. We're very focused on having a number of partner integrations launch with Cloud Spanner. And with our launch of Cloud Spanner Beta, we've had a number of partners come out with offerings pretty much on day one. So these are partners that provide you with bidirectional data migration like Xplenty, or visualization partners like Looker and Tableau and iCharts. And we have a number of committed partners, and Tableau is one of those actually, where they've committed to providing deep integrations into the Cloud Spanner platform to provide you with the same capabilities that you're getting out of those platforms, but with the scale and the benefits that you get with Cloud Spanner. I want to touch upon some of the material within the Cloud Spanner 201 session, and I thought it'd be very useful to go through perhaps a sample migration scenario. And this particular customer we work very closely with. They're called Quizlet, and they're a great platform for learning. They provide online flashcards and things like quizzes for learning pretty much any sort of material at all. The sort of database architecture that we're using there is very, or should be very familiar to anyone that's tried to scale out a relational database for a web application. So master-slave replication, replicas to scale out your reads, another replica for basically creating database snapshots for backups, and then some sort of memory caching for reducing the load on the database layer. They were hitting the limits of this sort of scale-out architecture for relational databases, and they couldn't do things like scale out both their writes and their reads. So what they basically did was they moved to Cloud Spanner. So to do some testing, they took some of their most highest loaded tables, or the most heavily loaded tables, I should say, and moved that over to Cloud Spanner. This is the schema definition for one of those tables, which I believe has a bit less than a terabyte's worth of data, but it was one of the most heavily hit within the database. You'll see that the schema definition looks very, very familiar. There are some changes when you look at the Cloud Spanner version of the schema, and that's the right-hand side. The left-hand side of the DDL, or the left-hand DDL, is actually what you see within MySQL, but pretty much the schema looks the same. There's some changes in terms of the primary key that's being used to accommodate how data should be scaled or distributed rather across the distributed system that is Cloud Spanner, and they had to basically replace an auto-incremented integer as the primary key with a more universal unique identifier to make sure that the data is distributed and sharded. But other than that, it's been a fairly straightforward looking migration in terms of that table. And then looking at the performance characteristics, where we're looking at their performance that they achieved for their specific workload around the median latency, comparing the performance of that table on MySQL versus Spanner is also very interesting. So here we see the limitations of a MySQL database or other relational databases. It's a proxy for that perhaps. And then we can see the power of the horizontal scale that we can achieve within Cloud Spanner and how that compares with each other. So whilst the MySQL median latency starts off lower than Cloud Spanner, we see that basically once we hit somewhere between 8,000 and 10,000 queries per second, MySQL hits a wall. Whereas Cloud Spanner basically provides you with horizontal, scalable, and consistent latency in terms of the median latency according to the size of the Cloud Spanner setup that we actually have. So depending on how much throughput you actually need, you'll need to obviously have the number of Cloud Spanner nodes to support that. But once you actually have the number of nodes to support the throughput that you need, you can see that the median latency is pretty much flat. The tail latency is also very interesting as well. So this is 99th percentile latency as throughput increases within the system. So one interesting observation is the fact that the Spanner 99th percentile latency is actually lower even for low query throughput volumes compared to a MySQL environment. But then if you look at the Spanner tail latency and the fact that it's completely flat up to the point of the limits of the number of nodes that you have within your Spanner cluster, that's a really powerful demonstration of the horizontal scaling characteristics of the system. So if you actually have a close look at the graph, you'll see that there's actually very little overhead. And then basically the fact that Cloud Spanner is also scaling the read and write throughput pretty much almost in a linear fashion without a great deal of overhead on top. Right, and so with that, I want to go into a short demonstration, and yep, I'm absolutely okay for time apparently. So I'm going to go out of my presentation, and I'm going to go to my Cloud Platform project. So this is a project that I've pre-created, and I'm going to go to Cloud Spanner. And I'm going to show you basically how you can create your first Cloud Spanner database. So I'm going to click on Create Spanner Instance, and I'll give the instance name something that, or somebody that would typically use Spanner, and that's Mechanic. And you'll see that the instance ID is automatically populated. I talked about regional instances versus multi-regional instances. Today we have regional Cloud Spanner instances, which let you target Asia, Europe, and US Central and distribute across the zones there. So today I'll specify Asia because of the region that we're actually in. And then I can basically create or specify the number of nodes that I actually need. So if you expand the performance guidelines, you also get some advice as to how you should basically scale out your Cloud Spanner instance. I'm going to click on Create, and that's basically going to create my instance for me. I also mentioned that multi-regional Cloud Spanner instances will be also available later on in the year, and that'll give you 5 nines worth of availability versus 4 nines that you get with the regional instances that you get today. So having created the instance, I can create a database within that instance. So I'm just call it DB. And then basically I can add tables directly via the Cloud Platform console. I can add some columns like a singer ID. I make that int64 and make that not null. I'll add another column. This time it's a string to identify the singer name. Oh. I made too many clicks there. Oh, let's go add table. Oh, I don't know what I did there actually. Let me delete that, and maybe I'll just go continue. Right. Okay, I don't know what I've done there. Maybe it's a browser problem there. Maybe I'll just go to my pre-built Spanner instance, and I'll show you something that I've preloaded into the database. So no doubt that was probably a user interface issue that was probably the problem, or where the problem was between keyboard and chair, so to speak. So I'm going to go to my pre-baked Spanner instance. I'm going to go to preloaded, and luckily for me, there's already a database in there with a number of different tables. So I've got account, I've got tables called ticket. This is actually a database that represents a database for an application for selling tickets across the world. These could be concerts and things like that, which is why you see tables like ticket and ticket category and so forth. One thing that you could do within the console is that you can actually create a query and execute that query directly within the web console. So because I am not very great today at creating queries and making tables on the fly, I'm going to take some pre-baked queries here and execute this within the console. So you can see that this query is something that looks very similar or very familiar to anyone that knows about SQL. And here within the Cloud Platform console, we can basically get back the result set pretty much in an easily consumable manner. We're also able to see the query plan as well if I were to click on the actual right button there. So let me just execute that again. And I'll click on explanation. So although Cloud Spanner underneath the covers performs a lot of magic in terms of how we do the horizontal scaling distribution, the complete query plan of how we execute those queries is made as something that's very transparent to you as the database user. So here we can basically see there's some map operations, there's scanning of indexes, and some other things. So if we actually hover over some of these actions, you'll get a full explanation as to what's actually happening for that particular operation as well. So the query itself took about 170 milliseconds. So we can actually improve upon that a little bit, perhaps by telling Cloud Spanner or giving some hints that we should be using some indexes to optimize performance. So in order to do that, I'm going to alter my query a little bit so that now I'm including some hints to tell Spanner how I should execute the query. So the differences here are the fact that we're including some clauses here where we're telling Spanner to use some specific indexes. So these are ANSI SQL 2011 extensions that we've added onto the system that's more specific to Spanner. So we're actually applying indexes across two different columns here that we weren't actually doing before. So whilst this query took 170 milliseconds, we should see improved performance with the use of the indexes. Right. So that took 113 milliseconds, which is a lot faster. On the screen, it took longer because this is actually creating a connection and creating a database within Europe. But the actual database query itself was a lot faster with the index. So this is a very basic demonstration of what Cloud Spanner looks like from a basic usage perspective. I didn't get to show you exactly how to create a database table given my user interface skills today, but I want to click on one of these particular tables and show you that in order to create the tables, it's also the simple definition via a DDL that looks very familiar to your typical SQL user. So with that, let's go back to the slides. And before we go into Q&A, I wanted to just talk about next steps. So getting certified on Cloud Platform, there's a full certification program as well as a set of comprehensive trainings that you can take your training to the next level. There's also hands-on labs that you can basically partake in at quicklabs.com. Go to Coursera to sign up for online self-paced training. Spanner will be one of those things that you can sign up for. Or you can also contact us as well if you want to talk to somebody directly about your particular needs. And then lastly, we also offer a free trial as well as a free tier program where you can get your hands dirty without having to pay for that trial consumption. So with that, let's take a break, and we'll be back very shortly with some questions.
Hey Win, happy Friday.
Yeah, happy TGIF.
Happy TGIF. Good
or
to
soon
see
to
you
be
again.
TGIF,
Yeah.
right?
Yeah, we still have the beach behind us. This is where we will be tomorrow, or
You
very
mean it'll
soon.
be a real beach.
It will be a
next
real
time.
beach.
Yes.
Yeah. I guess we are very happy that the webinars went also well, and opened up for questions here today. So we have very similar questions to our first session. So let's just run through them.
Yeah, fantastic. Let's do that.
Cool. So you spoke a lot about Spanner and how it's a relational database, and we've had a lot of questions in regards to can we just use them as a drop-in replacement for, let's say, MySQL or Postgres?
Yeah, indeed. That's a very common question, not just for today, but it's actually a question that I get a lot personally. So the way I explain it is that Cloud Spanner is a database that provides you with relational semantics, strongly typed schemas that you get out of a normal SQL-based environment, but it gives you horizontal scalability. It is a relational database, but it is not a MySQL or it's not a Postgres environment, right? So if you're using a software framework, like you're building a Django application and you're using some libraries that expects to talk to a MySQL or to a Postgres environment, Spanner, rather, not MySQL, basically isn't that environment. It is a database on its own. It's got its own identity, right?
Yeah.
If you needed a MySQL or a Postgres, you would typically use Cloud SQL for that. And that gives you those specific database environments for your applications. If you want to move to Cloud Spanner, the fact that we support open standards, so the ANSI SQL 2011 compliance and the JDBC drivers and so forth, they help you to basically move over to Cloud Spanner in a much more seamless and integrated sort of way, or rather it smooths over a lot of the typical database migration type concerns.
Yep.
But there will be a little bit of work, and you saw that with the Quizlet table where we need to change some of the primary keys around. But it's not going to be onerous changes, but there will be changes, and Spanner is obviously not MySQL or Postgres, but we have those on the platform as well.
Yeah, and you obviously get a lot more advantages out of Spanner. As I understand it, it's a fully managed service for horizontal scaling.
Yeah, absolutely, yeah.
Is that a first in market?
So in terms of a fully managed relational database that horizontally scales, I would definitely say yes. It's something that we've innovated on for a number of years. So it is not new in the market in the sense of it hasn't existed until now. We've been using it internally within Google for some of our own systems like AdWords and so forth for
like 10
over
years,
5. Yeah, over 5 years is on the slide, but it's been probably more like 10 years.
Yeah.
And it's been completely battle tested. So it's a cloud platform first, and we're really excited to be able to give customers, developers, organizations, whoever you are that might need a really powerful relational database that scales horizontally, the same power that we've been using within Google for a long time. But yeah, absolutely, it's differentiated as a managed service as well, that you don't actually have to do any sort of
So you don't need to
administration
worry
for that.
about it at all.
Exactly. So there's no spinning up of VMs. You don't need to go and size storage arrays and all that sort of stuff. MySQL on Cloud SQL, as well as Postgres and Cloud SQL will give you that as well. But Spanner is the horizontally scalable environment that also provides that sort of higher throughput than what you get with a MySQL or Postgres.
Cool. Yeah, awesome. And then the next question, or like a lot of questions fell into that same sort of area, was about migrations of data. How do we actually get our data into Spanner?
Okay, yeah, that's also a common question as well. And here I think there are different approaches to how you might look at that problem. So some of our customers have written their own migration tools to basically perform that. And we actually published quite a comprehensive guide on best practices for migrating large amounts of data in the most efficient manner possible. We actually focused not just on great best practices documentation, but the overall documentation in general has had a lot of focus and is part of the reason why Cloud Spanner was actually in a closed evaluation with a number of, a smaller number of customers for, I think it was over a year actually, because we were trying to basically make sure that everything was transparent, all the documentation was up to scratch before releasing this out. So you can consult the best practices documentation, or you can look at some of the partner integrations that we have that basically provide you with that data migration service in and out of Cloud Spanner. So I talked about partners such as Xplenty that provide services or technologies like that. And if those particular solutions, like do-it-yourself or using a partner-based technology, doesn't suit you, then we invite you to basically talk to us. And that's where I think a deep engineering-centric engagement with our customers really provides a lot of value back to those customers. And we can work with you on what your specific requirements are and how we might accommodate your particular requirements in a very customized way, if that is basically the approach. And a professional services organization, I believe, would be a key part of that story. And that's where you come from, right, KJ?
Definitely, yeah. So we have a new professional services organization within Google, and we definitely look into building customer solutions like this one. So, but as Win said, if you build a migration tool for, let's say, Cloud SQL or MySQL on premise, definitely let us know, open source it. We might, extend it or
absolutely.
Make it available for the rest of the world.
Yes, absolutely.
We have a few more, two more questions. When we're looking at other high-performance relational database offerings in the market, how does Cloud Spanner compare to it? I think we've covered it before, but just to re-emphasize it, it just comes up again.
Absolutely, yeah. So there are a lot of interesting innovations out in the market today. So I think Cloud Spanner basically provides you with a differentiated offering that's fully managed. It does all the replication underneath the covers, but it also allows you to basically scale out both your read and your write workloads, which is something that's really kind of incredible. I think depending on what you're looking at, sometimes you're still limited by a single master for particular types of databases, right? And whilst you can basically scale out your reads horizontally, you're still limited in terms of having that single master, which limits your write throughput. Cloud Spanner is a fully distributed system that allows you to basically have a horizontal set of nodes. Today it's in the Cloud Platform region, and soon it'll be basically multi-region as well. And that'll let you basically scale out all of your different access patterns that you actually need out of your database environment.
And not there's no concept of masters anymore.
Exactly, yeah. Indeed, there's no such thing as a master within the Cloud Spanner environment as far as what you see within the Cloud Platform console.
Okay, cool, awesome. Last question before we go have a beer, finally.
Yes. I think we've earned it, right?
Yeah, we definitely earned it. I think I hope you think so too. So how does the global replication put customer data at risk, or does the global replication?
I was going to say, I don't think it puts customer data at risk. And I talked about some of the enterprise-ready features that we actually needed to have on day one. And some of these we leverage as native capabilities that Cloud Platform provides. Everything is basically encrypted at rest as well as within transit. Cloud Spanner as a system that sits within Cloud Platform and our cloud in general also leverages that same secure encryption. And the fact that we replicate data across distributed systems, I don't think that exposes you to security risks because we protect that data from an in-transit as well as from an at-rest perspective. But you also, if you wanted to limit your data distribution for other reasons, then you can actually have both regional deployments as well as multi-regional deployments, right? So the actual question here is, well, global replication. But if you actually didn't want to have a multi-regional instance and you want all your data in, let's say, within the Asia Cloud Platform region, then you can basically do that as well, right? And I think the enterprise auditing capabilities that we have out of the box, as well as out of the cloud rather, we don't have a box here, or the IAM policies that we've also integrated deeply into the platform that let you in a very granular way specify who can do what and allow you to understand what those changes are in your system. I think that provides you with a great comprehensive kind of security story on Cloud Platform and Cloud Spanner. And
then on the Google Cloud Platform, you also have the data never leaving the Google's network. So this is a big differentiator as well. We never go over the public internet. So it's all within Google's network. And yeah, multi-region deployments are coming late 2017, was it? Or?
Yeah, well, yes, I'm going to stay with that. 2017 is what I'll say.
Yeah, so I'm just going with late.
Yeah,
okay,
absolutely.
with that we're finished for tonight, and yeah, we're going to the pub.
Thank you, and hooroo. So before we go to that though, I think we have just one more thing to do.
One more thing to
and
do.
we'll just bring up that last slide. And again, we encourage you to get certified on Cloud Platform. It's a wide range of capabilities, and I think you'll find something in there exciting. And certification will do great things for your career as well. Do you get your hands dirty with some of the hands-on labs, or sign up for a self-paced training course on Coursera? Feel free to contact us as well. And we're very interested in engaging with our customers at an engineering-centric level, or talk about what your business problems are and how we can actually help. Sign up for a free trial, so you don't need to basically spend your money to evaluate the capabilities of the platform. We also provide you with a free tier as well, which gives you some resources that you can run perpetually, which will also help you to get your hands dirty. And then lastly, there's a point around G Suite learning. G Suite's our collaborative productivity platform for messaging, as well as for document editing and collaboration. Do learn about that as well if you have those needs within your organization as well. So with that, thank you very much. KJ and I are off to the pub for a bit of a beer to go with our TGIF.
And the last session of the webinar series is going to be Jay presenting out of Singapore. So we hand it over to you in Singapore. Bye, Jay.
See you guys.